Good afternoon to one and all. I, Purva Shukla, welcome you all to Indore Institute of Science and Technology, an international webinar on Introduction to Machine Learning, which is hosted by IIST Indore at the Department of Computer Science and Engineering and Information Technology. For that, we have with us Honorable Chief Guest Director General IIST IIP IMR Shri Arun S. Bhatnagar Sir, Honorable Principal IIST Dr. Keshav Patidar Sir, Honorable Principal IIP Dr. Dinesh Mishra Sir, Honorable Principal IIMR Dr. A.K. Singh Sir, Honorable Dean Computer Science and Engineering and Information Technology Dr. Rajkumar Jain Sir, respected HODs of all the department and keynote speaker of the day Dr. Filbert Hilman Juwono, and all the dignitaries, faculty members and participants. We welcome you all. As an institution, we are committed to excellence. We work to develop creative thinking skills, unique innovations, and critical thinking among students. We are committed to enhance the employability quotient of student with holistic development. Toward these objectives, we have a special interest group on emerging technology. Apart from this, we have 27 clubs for extracurricular activities, games, and sports. The various societies focuses on the capacity building of the faculty and students and enable them to
Recording in progress.
Related to training, research, and development in the emerging fields. Code of competence and emphasis on quality at every level, right from the institute canteen, wherein we provide organic vegetables freshly grown in our agriculture fields under the Green Wave clubs. To classroom teaching by adopting best practices is a prime motto. Behind these innovative ideas is our Honorable Director General ISC IIP IMR Shri Arun S. Bhatnagar Sir, IRS ex-Principal Commissioner. It's my honor to introduce Sir. Sir has overall glorious of 45 years of work experience. Sir started his career as Assistant Professor of Economics in the year 1975. He has appeared in civil services exam and joined Indian Revenue Service IRS in the year 1983 and worked on a very sensitive assignments in different parts of the country and finished the Executive General Management Program conducted by IIM Bangalore. Sir has also completed prestigious courses from Duke University and University of Maryland, USA, and got most prestigious award for the best practices instituted by the Ministry of Finance, Government of India. After superannuation from the post of Principal Commissioner of Income Tax Department, he worked in corporate sectors where he headed business development and marketing till 2017. He was invited to join ISC Group of Institution as the Director General in the year 2017. Within a very short span of time, he has taken this group of institution to new altitude as this year admission statistics has escalated by more than 300% in management and 400% in engineering college with intake of students across the country. Sir initiated Green Wave Club, an ongoing program wherein student and staff members are participated in tree plantation and organic farming. The organic vegetables and crop cultivated in the campus are also used in canteen of this institute. Sir's hobbies are meditations, golf, badminton, debate, music, drama, and poetry. We welcome you, sir. May I request you, sir, please throw light on the today's webinar. Sir, please.
Thank you. Thank you, Purva.
Yes,
sir. Dr. Philbert, it is our honor that you are participating in our webinar, and I'm very grateful to you, sir, that you have given your consent. And we are looking forward with your university and with yourself for future collaboration, both in research and project work, and whatever way you will suggest. So our team is ready for that, and I again welcome you here. As far as the machine learning is concerned, I am not an authority in it, but I was very much excited after seeing the three words described by the Tom Mitchell from CMU University, USA, that he said E, T, and P. So I was interested, what is this ETP? Then he said it very well, that machine learning as a computer program that is said to learn from experience E with respect to some class of task T and performance measure P. If it performance at task T as measured by P improves with experience E. So this combination of, it was very exciting for me to read again and again I was going through this thing. So in simple words, it means the essence of machine learning is when a computer program can improve how it performs a certain task compared to its previous performance. You know better, but I was very exciting with these three words, ETP. From as a management student, I was looking forward to where this ML will go. Scientific concepts and computer science concept you will explain. But from my point of view, I was just thinking that I was reading one research conducted by Gartner that three major trends may appear. One is that pupil centricity. Business needs of human resources are demanding the assistance of IT. It's very clear to all of us. There's no ambiguity about it. Then second thing should be the locational independence. So that is, we have seen in work from home and everything, this brick portal model is going to demolish very soon. And third is resilient delivery, that business needs to adopt the changing scenario to survive. Distraction, jo ho raha hai. We have to adopt the new technology. We have to go to a new paradigm shift in the business models. So that's three things were quite attracting. And I was going through that machine learning is now used very comprehensively by big brands like, for example, Nike, using machine learning for personalized product recommendations. In F&B industry, Domino's, there's 10 minutes pizza delivery time. And I think BMW is using machine learning to analyze the data from vehicle subsystem. So these are the very big industries, they are doing it. And in 2021 onwards, it will go further because it will come to various industries. So 5 industries I was looking that where they will use more machine learning and artificial intelligence. I was told that the AI scope is will be around by 2028 will be around $1,000 billion. I couldn't add zeros in that. It was beyond comprehension. So I left it like that. So because there are 5 areas where ML will be used intensively, that is retail marketing, travel, of course, healthcare, finance, and media. For example, in healthcare industry, all the clinical decisions will be through large volumes of data will be used and machine learning can help. It will also help for our pharmaceutical students. I will tell them a huge process in drug discovery and cutting down the long discovery and development, and it will reduce the overall cost. So that is for pharma industry, it is a very big thing. As far as my sector is concerned, banking and finance sector, definitely machine learning, and we are also adopting in our revenue department to fraud detection and automating processes. And particularly share market is also using nowadays in trading, investment modeling, risk prevention. So what I would like to tell my students is that AI and ML is the future, and you have to give a lot of emphasis and try to go in depth in these areas. As far as other sectors concerned, like media and entertainment, everybody is aware that Amazon and Netflix are very popular and they are using machine learning in a big way. Because I think for predictive modeling, if I am putting something as my choice in YouTube, I will see to it all the films. Suppose I am seeing Crown in Netflix, so they will recommend, if you have seen Crown, now you can see this film, this film, this film, this film. Yeah, Designated Survivor or Madam Secretary, immediately I will get the serials like that. Likewise, in as far as other industries concerned, retail and commerce, we are all aware that after this COVID menace, there is a rapid growth in e-commerce, and all the companies are using machine learning to reinvent their supply chain, inventory management, predicting users' behavior, and analyzing trends. So this is wonderful. Driving prices emerging as key machine learning. That is also there. You can see your prices comparison in a competitive world, and there also you can use machine learning. And manufacturing industry, of course, that will be huge amounts of data in can be used. Automation. real-time error detection, and warehouse efficiency, of course, cost reduction, and even asset tracking. Also, we can use machine learning. So I was going through the various industries in US, like Yelp. We are using machine industry. I would like to tell my students in around 10, 15 very popular industries in US, they are using machine learning. Where Yelp, Pinterest is using, because Pinterest recently acquired a company called Cosi, a machine learning company that is specialized in the commercial application of machine learning technology. Likewise, Facebook, they are having chatbot of army with them. And Twitter, they are using machine learning. Likewise, Google, that is, if you will miss something, you will not talk about Google. The most visible development in Google's neural network research has been the deep oblique mind, what they say, network. That is machine, machine that dreams, machine that dreams. So Google is using virtual all aspects of machine learning. All aspects of machine learning Google is using. And if our students are very keen to join Google, they should go for this. And EdgeCase is e-commerce company, they are using machine learning. Likewise, the very important Baidu, that is, professor is aware that Chinese company, I think, Baidu, B-A-I-D-U, they have developed called deep voice. That is very interesting. That deep voice is a deep natural network that can generate entirely synthetic human voices that are very difficult to distinguish from genuine human speech. Now they have developed deep voice 2. That is deep voice technology. And this is going to be a real mind-boggling thing, voice search and voice search applications through this. Next, maybe HubSpot, fine, they are also using. Next is, this one thing I will definitely mention, that is IBM Watson. So Watson is a founder of IBM, if I am correct. And they said it's a IBM Watson. It is a questioning answering machine, and particularly used in hospitals in recent years, where it demonstrated its aptitude for making highly accurate recommendation in treatment of various certain types of cancers. So this is a very exciting field, Watson machine learning. And likewise, Salesforce, they are all using. So it's, my dear students, is a very, very exciting field. And next decade, if I am not wrong, my professor Hilbert will correct me, it will be an era of 3 things. One is artificial intelligence and machine learning, then nanotechnology, or third is data science. These 3 things will dominate the world. Our students should gain as much as possible skills so that they can match with the industry requirement and international requirement. They should not only eye for India, they should eye for the world market. I wish you all the best to my dear students. I again welcome Dr. Philbert. Thank you very much, sir. Thank you very much.
Thank you, Mr. Arun.
Thank you so much, sir. Thank you so much, sir. Machine learning has been part of our everyday lives. For example, all the smart devices we wear are based on machine learning technology. In fact, machine learning is one of the enabling technology for future society 5.0. Machine learning heavily depends on the data and is usually designed for a specific purpose. In this talk, we will revisit the fundamental of machine learning. Subsequently, we will discuss 3 applications of machine learning in biomedical, human-computer interaction, and agriculture fields. With a great opportunity, I present to you is Dr. Filbert Hilman Juwono. Dr. Philbert Hilman Juwono received the PhD degree in electrical and electronic engineering from the University of Western Australia, Perth, UA, Australia in 2017. He is currently a senior lecturer with the Department of Electrical and Computer Engineering, Curtin University, Malaysia. His research interests include signal processing for communication, wireless communication, power line communication, IoT, machine learning application, and biomedical engineering. He was the recipient of the prestigious Australian Award Scholarship in 2012. He served as an associate editor for IEEE Access and a review editor for the Fortering in Signal Processing. Now I request to you, sir, please take a charge and address the session. Sir, please.
Okay, thank you very much for the introduction, Ms. Purva.
Yes, sir.
I will share my slide.
Yeah. No, yes, sir, visible. Yes, sir, it's visible.
Okay. Okay, thank you very much.
Yes.
So, good afternoon to Director General, Mr. Arun Bhatnagar, and all panelists, colleges, students of Indore Institute of Science and Technology. As mentioned by Mr. Arun, that machine learning will be part of our everyday life in the future, because we will go to the society 5.0, where everything will be connected, and then we will use the data to gain information for our lives. And then, for example, also you can use machine learning for gaining profit, for example, for predicting the shares price, something like that. Okay. So I think that machine learning is a very important tool for us to learn, and then for us to master for the future applications. So thank you for inviting me as a guest speaker today. And in this topic, I would like to present about introduction to machine learning and its applications. This is the agenda on what we will cover today. First of all, I would like to introduce you to Curtin University, Malaysia, and then we will go to the machine learning introduction, including the types of machine learning, and also I will talk about two applications. So because of time limitation, so I exclude the third one, the agriculture application. So I will focus on the two applications for biomedical and human-computer interaction. And then finally, we will conclude this talk. Please allow me to introduce myself as well. So currently, I'm working at Curtin University, and then okay. Currently, I serve as an associate editor for IEEE Access and also a review editor for Frontiers in Signal Processing. My research interests are on the signal processing for communications, biomedical engineering, and as well as machine learning applications. So currently, I have secured 2 grants related to machine learning together with my colleagues at Curtin University, Malaysia. So the first one is from the government of Malaysia. It's the Fundamental Research Grant Scheme. So we are working on news detection. And the second one, just currently, just last month, I think, is from the Asian-India Collaborative R&D. It's about crop and wheat discrimination using multispectral images. So in the second grant, we are collaborating with Banastali Vidyapit, and also University of Indonesia. Yep. So next is I will introduce Curtin universities. So actually, Curtin Malaysia is the largest international campus and global hub in Asia of Curtin University. Actually, Curtin University has 5 campuses in Perth as the main campus, and then we also have campuses in Mauritius, Malaysia, Singapore, and also Dubai. So all the offshore campuses have good collaboration with the main campus, and we also have research collaboration with the main campus in Australia. In Curtin, Malaysia, we have 3 faculties and 2 schools. We have Faculty of Engineering and Science, Faculty of Business, Faculty of Humanities and Health Sciences, and also we have 2 schools, Curtin Malaysia Graduate School and School of Professional Advancement and Continuing Education. So these are the achievements of Curtin University so far. So in 2021, we ranked 217 in the world and also 17 for the universities under 50 years. And we are top 200 for electrical and electronic engineering, top 350 for computer science, and yeah, for the Bachelor of Technology and Bachelor of Science, yeah, top 350. All right, so that's all for the introduction of Curtin University, and then we will, sorry, that one. We will go to the main focus of this talk, and then I will introduce about artificial intelligence as a whole. Okay, so actually the artificial intelligence is the development of computer systems that are able to perform tasks that would require human intelligence. So as you know that you have seen chatbots, right? Human versus computer games. Maybe you are playing the games, something like Sudoku, yeah, or maybe what else? The chess, yeah, chess games. Okay, so they are all use machine learning. They are use artificial intelligence, right? And then for you who are watching Iron Man, right? You know Jarvis, right? Jarvis is the AI application, AI assistant, yeah, for the Iron Man, right? And also Doraemon, right? Doraemon is a very advanced robot. Okay, it's coming from 22nd century, right? So actually, the AI can be categorized into 3 types. So we have the weak AI, strong AI, and also super AI. Okay. So weak AI is AI which has been designed to do one particular task only. So most of our AI applications are weak AI, yeah, belongs to weak AI. For example, it's Siri and Alexa, right? Siri, Alexa, and also our recognition system, face recognition system is one examples of weak AI because it only designed only for one particular task. Yeah, and then strong AI. How about strong AI? Strong AI exhibits human intelligence actually. So maybe you can consider something like Doraemon or Jarvis, right? Doraemon has an intelligence similar to us, to human, right? But actually, of course, we haven't found that the strong and super AI. Okay, so currently we are in the era of weak AI. Maybe in the future we can develop a robot, something like Doraemon, okay, or maybe something like Jarvis. Yeah. How about the super AI? So super AI is the AI that has surpassed human intelligence. So actually, we don't know about this super AI. Yeah, one of the examples, yeah, I found in literature in Google is that maybe you know that robots intervention to the earth, right? It's something like robots has intelligence beyond the human, okay? The intelligence of the robot beyond the human intelligence, so actually we cannot control them. Or maybe it's one of the examples of super AI, but for now, I don't know. I cannot imagine the super AI, right? This is one of examples also in artificial intelligence is about the autonomous car. So an autonomous car has equipped by many sensors, such as lidars and also cameras. They are used to obtain the data, and then the data can be used to make decisions. Actually, for example, the data can be used to calculate the safe distance, so that the car knows when to slow down, and so on. All right. So this is very interesting example of artificial intelligence. Also, it's very complex design, right? Basically, AI is the umbrella for both machine learning and deep learning. You have heard about machine learning. You also have heard about deep learning. So actually, they are part of artificial intelligence, right? So machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning, right? So in short, that machine learning is algorithm for learning the data, because as you know that all the learning, both machine learning and deep learning depends heavily on data. That's why we need data science. We need data. Data is very expensive. And deep learning here, deep learning is a subset of machine learning, and also it uses neural networks for learning the data. Later we will cover both machine learning and deep learning. So there are some machine learning definitions as mentioned by Mr. Arun Bhatnagar. Okay, so first we want to know what is meant by learning. Okay, Herbert Simon says that learning is any process by which a system improves performance from experience. So actually, not only the system, but also that human brain is also a system, right? It improves our performance from our experience, right? We learn how to sum, right? How to sum numbers, right? And then perhaps we got wrong, and then from that one we learned that of course 1 + 1 is equal to 2, not 11, right? 1 + 1 is equal to 2 from experience, right? So this is the general idea about learning. So we will continue to the machine learning. How about machine learning itself? Okay, definition said that machine learning is a field in computer science that uses existing data to predict future data. So once again, that machine learning uses data as the main element, the main element. Without data, machine learning is nothing, right? So in this definition, we see that we can know the future based on the existing data. It's something like we can predict the end, maybe the end of COVID-19 pandemic, right? Currently, with G.H. Raisoni College of Engineering, we are collaborating on research, and then one of the topic is to predict when the COVID-19 pandemic will end. We use the existing data. We use the vaccination data, the virus data, And then we hope that we can build a model to predict what happens in the future. Yeah. And then the second definition, so we can see that machine learning is machines, yeah, which consists of computers, software to produce the model from data. So the model will be used to predict the future, yeah, to predict the future from the current data. So actually, the second definition matches with the first definition, right? This one is the very famous definition of machine learning, as mentioned previously by Mr. Arun, that according to Tom Michel, machine learning is a study of algorithms that improve their performance P at some task T with experience E, right? So I have one example here. So for example, you want to detect, your email wants to detect whether the incoming message is spam or not, yeah? For example, your Gmail or your Yahoo Mail, something like that. So we have three components here. Yeah, we have three components. The first one is the task. So the task will be to classify emails as spam or not spam. So in this case, we have binary classes, right? We have binary classes. We want to categorize, we want to classify the emails as spam or not spam. Let's say that spam is 1, not spam is 0. So between 0 and 1, right? Whether this email spam or not spam. So how the system learn? As I mentioned previously, that the system, the machine, and the software needs to learn. Yeah. How the system knows whether the message, for example, the advertisement message, right, is a spam, right? Because the machine watches you when you label the email. Yeah. For example, that you will click the email, the advertisement email, as spam, right? And then the machine will learn, yeah, what if you categorize this email as spam, what makes you think so? Yeah, for example, yeah, it contains the word advertisement, yeah, something like that, yeah, or maybe contain the word sales, yeah, discount, something like that. Yeah, it's an advertisement of buying something, right? And then the machine learns about that one, right? And then this one is the experience, yeah, experience of the machine, right? And then how about the performance? Yeah, when you do labeling, yeah, 1 time or 2 times, and then the machine still categorize the same email as not spam, then it means that the system has not learned, yeah, has not learned about the how to classify the message, yeah. Therefore, the machine needs to learn again and again, right? So there are three elements here. Okay, the P is to classify. The P, the performance, the number of emails correctly classified, whether this one is 100%. If 100%, then it means that the machine has learned, yeah, or maybe 50%. Okay. Someone is raising hand, so should I continue or? Okay, I will continue first. Okay, later we can have a question and answer session, Q&A session later. Okay. Okay, and then the E, the machine watches you labeling the emails here. All right, and then this one, another famous example. We want to recognize handwritten numbers here. Okay, we want to recognize handwritten numbers. So as you can see here, that number 2, for example, how you write number 2, yeah, it's not consistent. It's not very consistent, right? How can the machine can, for example, how can you recognize this as 2? Yeah, how the machine can recognize this as 2? Yeah, I think this one is similar to 7. All right. Okay, how about this? Yeah, for example, is this 3 or what? Yeah, because the handwriting is not very consistent here. That's why the machine needs to learn from the data here. So the data here, yeah, are not many, right? But just for example here. Yeah. So what is the task here? The task here is to recognize the handwritten numbers 1 to 9. And then the performance is the percentage of the handwritten numbers correctly classified or recognized, right? And then the E, the experience, is the labeled handwritten numbers. So we need to provide the label. So this one, yeah, these 3 numbers are 0, yeah, and then these 6 numbers are 1. Yeah, we need to give our labels, yeah, the labels to the machine to learn. Yeah, of course, the machine needs to identify the features from this handwriting. Okay, so later we will see how about this. Okay. Okay, so how does machine learning work? So actually, there's one illustration here. So let's say that there is a baby Andy, right? Baby Andy is learning about cars from the picture book. Yeah, so there are 2 types of cars here. Yeah, this is the first type, and then the second type, and also so many other pictures of cars, right? After 1 year or 2 years reading the book, right, Andy can recognize his family car. Okay, so the family car is something like this. Okay, as you can see that the family car is quite different from what he learned in the picture book. Yeah, yeah, of course it's very different from this. Yeah, it's very different from this, right? But surprisingly, Andy can recognize his family car. Yeah, oh, this is our family car. So why? What happens to Andy actually? So actually, Andy can generalize the learning. Yeah, can generalize the model of a car. And for example, he learns that maybe a car has 4 wheels. Okay, and then a car has 2 lamps, yeah, in the front, and 2 lamps, yeah, in the back, and then maybe 4 windows, right? That's why he will not say that a truck or a train as a car. Yeah, it means that Andy can generalize, yeah, what he learns, yeah, from the picture books. So likewise, machine learning is intended to generalize things from the labeled database. Yeah, that's the perfect machine learning. Okay. So when do we use machine learning? So actually, the first one is we use machine learning when we are facing something beyond human expertise. So for example, Mars navigation, as you can see from the news, that AI is helping scientists discover predators on Mars. Yeah. Okay. And then the second is humans cannot explain their expertise. For example, is about speech and face recognition. And for example, something like this, we have some some pictures of the same man. Yeah. So actually, we can say that the figures are coming from the same man. But actually, I don't know how to explain to you. Yeah, I don't know how to explain to you. So why this picture and this picture is the same? Because I can say that maybe the shape of the nose the same, but how about this? The shape of the nose is quite different, but we know that this one is the same person, right? But I cannot explain to you why this one is the same person as this one. Okay, so yeah, by our intuition, we know that the person in the pictures is the same man, right? So we need the machine learning. Okay, and then the third one maybe is about the personalized models. So for example, personalized timetable or personalized medicine, something like that. Yeah, and then the fourth one, models are based on huge amount of data. For example, smart city or society 5.0. Yeah, in the future, maybe you know that all the data will be integrated. Yeah, will be integrated. Yeah, for example, a student in the university, so the university can get the data about the student from the hospital, something like that. So we know, oh, Mr. A has maybe asthma, or maybe has what has been infected by, for example, COVID. Yeah, maybe 2 years ago or 3 years ago, later in the future. So all because we will use the data to anticipate, for example, the medication. Yeah, they are all related to one another. Yeah, for now they are separated, right? We cannot access the data in the hospital. Hospital cannot access the data in the bank or in the university, right? So they are all have their own database. Okay. Okay. These are some common tasks using machine learning. The first one is recognizing patterns. Yeah, as you can see, the previous one is about the face recognition or maybe handwriting recognition, something like that. And also we can use AI to generate patterns. As you can see here, these are examples of examples of paintings that are generated using AI. Yeah, using AI. So they are not painted by human, yeah, but they are generated using machine. Yeah, and then in the future, maybe you can use AI as well to detect whether this picture, yeah, this picture is real picture or fake picture, something like that. Okay, and then we can use machine learning to recognize anomalies. Yeah, when I talk machine learning, it means that we can use either machine learning or deep learning, right? Or maybe any other artificial intelligence algorithm. Yeah, can be also reinforcement learning. Later we will see. Okay, so recognizing anomalies such as cyber attack. Yeah, because all the systems are connected to the internet. So maybe you will see that many people want to attack the system, yeah, for gaining personal profit, something like that. Yeah, so that the system must know whether there is an attack or not. Yeah, for example, in smart grid, yeah, smart grid or smart city, yeah, it's very prone to cyber attack, right? And then the fourth one is about prediction. It's something like when we predict the end of COVID-19 pandemic, or maybe we want to predict the stock price, yeah, for the next 1 month or 2 months. Yeah, when you want to buy the stock, maybe you can predict which one I should buy, right? Okay, so these are three important elements of machine learning. So first of all, it's data. As I mentioned again and again, that machine learning heavily depends on data. So in the future, there are huge amount of data. That's why it's quite related to what we call as 6G. Yeah, because everything later, let everything will be connected, and then will be connected to sensors, right? Sensors will bring the data, yeah, to the cloud, something like that, to be analyzed, yeah. And then how to bring the data to the cloud? We can use maybe wireless, um, or maybe wireline, yeah. So the current wireless system maybe cannot enough. It's not enough to bring the huge amount of data. So that's why the researchers they do research. They develop the current 5G system to 6G system, right? And then the second is the features. Okay, features are measurable properties used as inputs in machine learning. And for example, when you want to know, when you classify the cancer, yeah, whether the cancer is harmful or harmless, yeah, we want to know the features. Yeah, we want to see the feature first. Yeah, the features can be, for example, the diameter of the cancer, yeah, the area, yeah, or maybe the shape of the cancer. Yeah, from the features we can classify whether the cancer is harmful or harmless, right? And then the next one will be the training. So as I mentioned before, that the system must learn, yeah, must learn. Okay, and then the purpose of the training is to create the model, yeah, for mapping the input to output. The input is the, for example, the type of this cancer, and then the output will be harmful or harmless. Yeah, harmful or harmless. Yeah, yeah, this is the input. Yeah, the new cancer figure, for example. Yeah, or yeah. And then this is the output, and this one is the model. Yeah, the model is generated from the training process. Okay, it's a map. Yeah. Okay. So actually, there are 4 types of learning. Yeah. We focus on learning, right? Or maybe we can say that it is training. Yeah, training or learning. Yeah, there are 4 types of learning. The first one is supervised learning. The second one is unsupervised learning. The third one, semi-supervised. And then the fourth one is reinforcement learning. Okay, supervised learning, we have the training data plus labels. Okay, and then for the unsupervised learning, we only have training data. Okay, and for semi-supervised learning, we have training data plus a few labels, right? And for the reinforcement learning, we have reward from sequence of actions. Okay, so in this talk, I will just focus on supervised learning, right? We'll focus on the supervised learning. Right. Okay. These are terminologies for supervised learning. We have labels, features, example, labeled example, unlabeled example, and model. Okay. Okay, so for labels, labels are variables we want to predict. Yeah, for example, when we talk about the email, yeah, the labels will be a spam or not spam. Yeah, spam or not spam. Okay, or not spam. Yeah, yeah. This one is typically we use Y. yeah, to denote the labels. Okay. For the features are the input, right? As I mentioned previously, these features are the input representing our data. Yeah, for example, in the cancer, it can be the area, it can be the diameter of the cancer, it can be shape of the cancer, and so on, right? And that example is one particular data, okay, one particular data. And then labeled example consists of features and label. Yeah, so for example, I can say that when the diameter is this one is, for example, one, right? It's 1 millimeter. Okay, diameter is 1 millimeter, and then the area of the cancer, for example, 0.5. Yeah, something like that. Yeah, then the label will be this one is the harmless. Yeah, harmless cancer, right? And we have so many data, right? For example, the diameter is maybe 5 millimeters, right? The label will be harmful, okay? Harmful cancer, okay? And then the unlabeled example consists of features, but no label here. So we want to predict the label actually here in the unlabeled example, okay? And then the model used to map examples to predicted labels. Okay, predicted labels, right? All right. So supervised learning can be divided into two types. The first one is regression, and then the second one is classification. Okay. So regression predicts continuous values. Yeah. Example. We use regression when we want to know the house price, for example, in California, yeah, or in India, yeah, or maybe we want to know the temperature in Japan, yeah. So we use regression, right? For example, I have this data, yeah. So X is the feature. So in this case, I use only one feature, and Y is the label. Yeah, label can be the house price or maybe temperature and so on. But I will not say anything about this Y. Yeah, just this one is the label. Yeah, so 1 will be mapped to 2.5, 2 will be mapped to 4. Yeah, and so on. Yeah, so we can create the plot, something like this. So this is our data. Yeah, this is our data. And then what we want to make here is we want to make a model, yeah, to map the feature to the label, yeah, the feature to the label. So because we see that this one is quite linear, yeah, we can use a linear regression, yeah, for this. Yeah, of course, you can see nonlinear regression later on. Yeah, you can explore yourself after you understand the linear regression. Okay, so this is the model. This is very simple model of a linear regression, right? Where Y is equal to B plus WX. Yeah, B is the bias. Yeah, we call B as the bias. Okay, as the bias, and then W is the weight. We want to find the weight and the bias. Yeah, for this types of data. Yeah, we have X. Yeah, the features, we have the feature, we have also the Y. Yeah, so we want to generate the model here. Okay, you can see that the model can be like this. Okay, can be like that, can be like this as well. Yeah, so which one is correct one? Which one is our model? Yeah, of course we want to create the best model, right? We want to create the best model. Yeah, to map the X and Y, right? Okay, so how to get the best model? So one approach is to minimize the minimum square error. Yeah, the MSE. The mean square error. Yeah, so we want to minimize the mean square error. Yeah, the mean square error is given by this formula. So the y minus the prediction, yeah, and then we take the square, and then we sum, yeah, and then we divide by the number of samples. Yeah. Okay, so we can use gradient descent algorithm, yeah, with minimum with the mean square error, then SE as the cost function. So this one is the cost function. Okay, so the prediction we put our model here, yeah, our model, right? This model we put here. So after this, we can calculate the gradient here, and then using the software, yeah, you can use either Python or maybe you can use MATLAB. For you who are coming from engineering, you can use MATLAB. Okay, and for example, here I use the learning rate 0.05, right? The learning rate is actually the step size, yeah, the step size, and then the number of iteration is 10. You can set 20, 30, and so on, right? But I think 10 is enough because the number of data is not many, right? And then we can put the initial values for W and for the weight and the bias as 2 and as 0 and 2, yeah, respectively. Okay, it can be anything actually. You can put 1 here, you can put 1 also here, yeah, 1 or 0 2, yeah, whatever. And then after that, when after you use the gradient descent algorithm, so you get this model, yeah. So this model. So actually, yeah, the green line here denotes the model here, yeah. By using this, we can get MSE equal to 0.5. So this one is actually the minimum MSE, yeah, we obtain from the gradient descent algorithm, right? So for example, using this model, we can predict the future data. Yeah, for example, I want to know what is y when x is equal to 11. Yeah, we just substitute 11 here, yeah, and then we get the y. Yeah, this is what we predict the future. Yeah, let's say x is maybe x is day or time, right? We can predict the future. Yeah, when x is equal to 11, 12, 13, 14, something like that. Yeah, by using this algorithm, this model, right? Using this model. Okay. Now, how about the supervised learning for classification? Yeah, classification means that we want to predict discrete values. Yeah, for example, it's about the spam or not spam, yeah, of the email, or maybe we want to classify an image, which is the image is a cat or a dog, yeah, or a sheep or yeah, or fish, something like that, right? This discrete values, right? So, for example, I want to classify whether a cancer is harmful or not harmful based on the size of the cancer. So we can say that if the size is this amount, this, for example, this one is 1 millimeter, so this one is not harmful, right? For 2 millimeter, then also not harmful, right? But there is a data, for example, when the size is, for example, 7, this one is harmful, yeah, but the size of 8, yeah, for example, 8, not harmful, right? It depends on the data. We cannot control this, right? We cannot control this, actually, yeah, based on the real data, okay? So this one is just for example, all right? And then we can also represent this scenario by using different picture, something like this, right? So the red one is the harmful cancer, and then the blue one is the harmless cancer, right? Based on the size, okay? And then we need to define the threshold. Yeah, we need to define the threshold, meaning that if the new data coming yeah, we can denote whether the cancer is harmful or harmless. Yeah, if the size belongs to this area, yeah, this one is the threshold, yeah, less than the threshold, then the cancer will be harmless. And then if the size is larger than the threshold, then the cancer will be harmful, right? Okay, so the point is how to find the threshold here. Okay. One of the algorithm we use for this classification is logistic regression. So once again, the example is, suppose we want to find whether the cancer is harmful. We can say that harmful is 1 and then harmless is 0, for example, based on some features. Yeah, we want to see 4 features here. For example, the radius, the texture, the area, the symmetry, yeah, of the cancer. Yeah, and then we can use the linear regression. Yeah, because we have four features, then we need 4 weights here. Okay, so this one is actually the same as this one, right? The same as this one. Yeah, but we extend this model for more than one feature. Okay, right, and then we change y to z here. Okay, and then for example, we get this weight, yeah, by using the gradient descent algorithm, yeah, the previously SGD, right, the gradient descent. We get the bias, the weight, yeah, and then there is a new cancer which has these properties, right? The radius is 17.99, the texture is 10.38, and then the area is this, and then the symmetry is 0.24, for example, right? And then you need to classify whether this new cancer is harmful or harmless. So you substitute the value of X to the model here, and also you substitute the weight, yeah, from the data. This one is coming from the database, right? Database. This one is a new data. Yeah, remember this one is a new data. And then you will get Z is equal to 6.23. Okay, Z is equal to 6.23. Then we can use a logistic equation, or we can say the logistic equation as a sigmoid, something like this, yeah, to convert the Z to probability, right? So this is the formula, yeah, for the sigmoid function, yeah, so sigmoid function here. So the y, we get previously Z is 6.28, so we substitute here, y is equal to 1 over 1 plus exponential negative 6.28, and then we get 0.99.81. So this one is close to 1, right? So it means that the cancer is harmful, yeah, right? Because harmful is 1, yeah, so this one is almost 1, right? So how about if the probability is 0.6? So it depends once again to the threshold. Yeah, how to find the threshold is another problem. But usually we put 0.5, but once again depends on the number of samples, the number of the data. Yeah, number of the data we can get. Okay. Next is about the evaluation metrics. So how can we, once again, we want to remember the T, the E, and then the P, right? The performance, right? We want to evaluate the performance by using the evaluation metrics, right? And then one of the metric is the confusion matrix. So confusion matrix is n times n matrix showing the success of the machine learning model, yeah, where the n is number of classes. Yeah, for example, in this case, we have 2 classes, whether this one is tumor or non-tumor, or maybe harmful or harmless, yeah, spam or not spam, right? But later it can be extended to more than 2 classes here. Okay, in this example, we see that if the cancer is the if the we have the tumor in actual actual case, but the machine learning, our model, predict as tumor. Yeah, tumor is predicted as tumor. Yeah, so I think that this one means that our model is correct, right? So there are 18, yeah, 18 samples. Yeah, they are correctly predicted. Yeah, how about this? How about the tumor? Actually, it is tumor, but our machine, our model fails to predict. Yeah, fails to predict. Yeah, so it predicts as non-tumor. So it should be, for example, this is 1. Yeah, so one case, yeah, one sample fails, right? And similarly, yeah, non-tumor is predicted as non-tumor is 452. Yeah, and then for the non-tumor is predicted as tumor is 6. Yeah, all right. So this is for example. Yeah, so we call it as a confusion matrix. Yeah, confusion matrix. And then there is there are terminologies for each of the numbers here. Yeah, we have a true positive, true negative, a false positive, and a false negative. Okay, a true positive is an outcome where the model correctly predicts the positive class. Okay, so this one is called a true positive. And then a true negative is an outcome where the model correctly predicts the negative class. It's a true negative is here. Okay. And a false positive is outcome where the model incorrectly predicts the positive class. Right? So this one is the false positive, and this one is the false negative, which is an outcome where the model incorrectly predicts the negative class. And then from this, you can see that actually the database is not balanced. Yeah, meaning that the number of the tumor, yeah, is only 19 here, right? But the number of samples for non-tumor is around 458. Yeah, so actually not balanced. Yeah, the samples are not balanced. Okay, this is one remark for this example. Okay, and then we can also define the accuracy. The accuracy is the number of correct predictions divided by total number of predictions. So in short, what is the accuracy of this? The accuracy is actually 18 plus 452, okay, divided by the total samples here. The total sample is 19 plus 400 plus 458. Yeah, so that's the accuracy of our system, our model, yeah, our machine learning model, meaning that we can predict correctly, yeah, tumor is predicted as tumor and non-tumor is predicted as non-tumor, right? This is the accuracy. But when the number of samples are not balanced here, yeah, so using accuracy is not proper. Actually, we can use different metrics, yeah, such as precision and recall. The precision is defined as the true positive divided by the sum of true positive and false positive, while recall is the true positive divided by true positive plus false negative. So in the previous example, the precision will be 18 divided by 18 plus 6, which is 75%, and the recall is equal to 94.7%. So what does it mean? So for the precision, it means that when the model predicts there is a tumor, so it is a tumor, so it is 75% correct of the time. Yeah, so 25% are not correct. Okay. So when the system, our model predicts, so this is tumor, so you can believe 75% actually. Yeah, that this one is correct. Yeah, you can believe it's 75%. How about the recall? Yeah, it means that the model correctly identifies 94.7% of all tumors. Yeah, so actually from this table, from the confusion matrix, we can say that only one sample is not correctly classified. Okay, so meaning that 94.7 of all tumors are correctly classified. All right. Okay, so that's all for the evaluation metrics. And then next, I will talk about the challenges in machine learning. So actually, this one is the diagram of how machine learning works. Yeah, so actually, we should have a training data, and then by using machine learning, we get the model here, and then we use the model to predict the another data of new data here, right? But the problem is the new data should be different from the training data. Yeah, if they are the same, then actually the output must be 100%. It's something like the baby Andy, right? Baby Andy, when he classify the same cars as he sees on the book. So of course he can do it. Yeah, he can do it. But the surprise is that he learned about the book from the book, right? Yeah, so it means that the input data here, okay, the input data here must be different from the training data. Okay, that's why we usually divide the data set into two, yeah, for testing and for training. Yeah, for training is usually 80% or 90%. Yeah, for testing is 20% or 10%. Yeah, and then the it should be independent, right? Now the problem is how distinct the data should be. Yeah, in some cases, yeah, for example, when we want to recognize voice of students, yeah, it would be impossible to get a good result when you test using foreigner voice, which has not been trained before. Yeah. So actually, I will see here, we will see later in our research that it's quite the terms of the distinct here is quite challenging. Okay. Yeah. So the question is how distinct the data should be. Yeah. The second one is overfitting. Yeah. The overfitting. So, overfitting doesn't show a generalization. For example, from the previous data, yeah, the previous data, yeah, I can write, I can build my model is something like this, yeah, something like this, yeah, compared to the previous one, this one, right? Previously is something like this, right? The red one, yeah, using the SGD, right? Yeah, gradient descent, right? We get the red one here, but of course I can build the blue one. Yeah, it means that when we measure the MSE, yeah, of course the blue one, yeah, will have lower MSE, yeah, compared to the red one. Yeah, the red one, remember that last time we got 0.5, sorry, 0.4. Yeah, the MSE is 0.4. Yeah, but when we use the blue one, yeah, here, of course the MSE will be lower than 0.4. The question that is it good? Which one is good model? Yeah, the blue one or the red one? Yeah, if we use the blue one here, it means that it is we have overfit. We have overfit the model. Yeah. Okay. So actually, overfitting means that we use the complex model Yeah, it has low loss during training, but it is bad in predicting new data. Yeah, actually, we want to avoid this one. It means that we do not generalize. Yeah, we do not generalize, but we want to generalize our model. Yeah, this is bad overfitting. So this one is in line with the Occam's razor principle. So actually, Occam's razor principle mentions that simpler model is preferred because it has low complexity. Yeah, we will see later in our research that Occam's razor principle really works. Yeah. Okay, so this is the remark for the machine learning. So actually, machine learning has the following components. The first one is representation. The second one, you must have the optimization algorithm, and then you need to have the evaluation. So representation can be one of the four. You can have numerical functions such as linear regression, neural network, or support vector machines. Yeah, later we will use. Yeah, I will use support vector machine for our research, and then it can also
I think there are some network issues. He will be back within a minute or two.
Hello, Dr. Philbert.
okay. Sorry about that one. My Wi-Fi suddenly off. Yeah. So
Okay, sir. No issue. No issue.
Continue.
Yes, sir. You can continue, please.
Yeah. Uh, I cannot share my screen.
Yeah, just a minute. Nilesh, just please make Dr. Philbert a co-host.
कोई है कि नहीं देखो
Yes, now you can share the screen.
Please share this.
Dr.
Okay.
Philbert, now you can share the screen, please.
Okay, so can you see this?
Yeah, we can see the screen.
Okay, okay. So I will continue. So actually, yeah, so we need to have 3 components when we are working with machine learning. Right. So next is, I want to talk a bit about deep learning. So actually, deep learning is just machine learning that employs deep neural network, and the concept will be more or less the same, but it has a deeper network. And then one of the machine learning, deep learning algorithm is the convolutional neural network, which we usually use for recognition. So the difference between machine learning and neural network is that in machine learning we use separate feature extraction, but will be together, combined together with the right? So we focus on the combination. Yeah, so this one is the feature extraction network, and this one is the classifier. So for the feature extraction network, actually it consists of convolutional layer and layer. Convolutional layer generates new images called feature maps, and pooling layer is used. Yeah, so this is the concept of the convolution layer. So actually, this one is convolution, and we have the filter, and we also have the activation function. It's actually the blue here. Why we need activation function? Because usually we deal with non-linear, so we want to have the non-linear behavior. So we the activation function or ALU, something like that. We can use the activation function. They are functions. And then the principle of convolution of the image is quite different from the convolution principle of a signal. So for example, we have a 4x4 matrix. This one is the pixel, all right, the image. And this one is the filter. This one is the filter. We want to convolve, yeah, the image and the filter. Yeah. So actually, we use sliding windows, right? And then, for example, we use this sliding windows here, 2x2 windows here. So we have 1, 1, 4, 6, and then we convolve with 1, 0, 0, 1. So actually, we get 7 here. So 1 times 1 plus 1 times 0, yeah, plus 4 times 0, and plus 6 times 1. So we get 7 here, okay? And then we move the window one sample to the right, yeah, so the window is now 1, 1, 6, 4. So we do the convolution. 1 times 1 plus 1 times 0 plus 6 times 0 plus 4 times 1. We will get 5 here. Yeah, and you will do way for filling the other elements, okay, matrix elements, right? That's the concept of convolution. And then the pooling layer, as I mentioned previously, that we need to reduce the size. So we have 2 types of the pooling. We have mean pooling and max pooling. Yes, so for the mean pooling, we take the mean of this values, right? For 1, 1, 4, 6, we take the mean, which is 3. Yeah. But for max, we take the maximum. Yeah, the maximum of this is 6. Okay. And then for this, okay, we take the mean, yeah, which is 4. Yeah, 1, 3, 4, 8. Yeah, the mean is 4, and then the maximum is 8. Yeah, and so on. All right. So we have 2 types of pooling. Okay, this is a concept of CNN. So later you can check this website for the details of the CNN, right? So actually, I want to say here that the convolution here, this one is, they are creating the features automatically. We can see, the features here are created automatically. It's different from the machine learning, right? Machine learning, we need to find the features ourselves, right? For example, for the cancer, we define the features. We can see from the diameter, we can see from the area, the texture, what else, yeah, and so on, right? But in the CNN, the features are automatically built here by using the convolution and pooling, right? One of the available architecture is the VGG. Of course, you can find other architectures such as AlexNet and so on. But why I show VGG, because I will use this VGG in the subsequent discussion, right? So see that this one is the dimension, right? The dimension is will be reduced, yeah, will be reduced. That's why we get a better feature. Yeah, we get better features, right? Different architecture will have different content and yeah, schemes. Yeah, different schemes like that. All right, so I come to our one of our research. Yeah, so deep learning in biomedical. So we want to predict for in vitro fertilization. So this work has been published in a conference paper in 2019 and also a part of a book chapter in 2021. Okay. Actually, as you know, fertilization is an assisted reproductive treatment to facilitate pregnancy process where the sperm and the embryo are combined, yeah, outside the body, right? So the problem is the success of IVF is still low because it is influenced by the goodness of the embryos. Yeah, as you can see, we have three figures of embryos. Yeah, so which one is the good one actually? So we know that the left one here is the excellent embryo. The second one is the moderate, and then the right one is the poor embryo. For us, we cannot differentiate actually. So that's why we collaborated with an embryologist, yeah, from a hospital. So she helped us to give the label, add the labels, because we use once again the supervised learning, right? We must have the labels. So she helped us to define the labels for the embryo images, right? And then we use the day 3 embryos, yeah, the day 3 embryos images, right, for this research. So actually, the quality of embryo depends on a number of parameters such as number of cells, blastomere, fragmentation, and so on. Yeah. So for the excellent embryo, it should have 7 to 8 cells, and then the blastomer must be similar, and then the fragmentation must be less than 5%. Of course, this theory is beyond my expertise, so that's why this one is determined by an embryologist, right? So there are three classes here. The one is the poor. Yeah, of course we will not use the poor embryos, yeah, for the IVF process. So this is the proposed method. Actually, we use the CNN model because we use the image, yeah, of the embryos. Yeah, the image of embryos will be input to the image filters here. So once again, the image filters here is quite different from the image equation. Yeah, in the CNN, remember? Yeah, we in the convolution layer we use a filter as well. Yeah, so it's not the filter here, right? This one is different filter. We call it as a image processing filter here. We have so many filters. So yeah, so we use median filter, Gaussian filter, Sobel filter, Laplacian filter, sharpening filter, and blur filter. Yeah, and also no filter. Yeah, no filter is the NOP. Yeah, no operation, meaning that we directly input the image. Yeah, not through the filter here. And then we have the sampling binary factor. This one is for choosing the filter we will use. Yeah, we can use all filters, or we can choose the optimal filters. Yeah, from the 1, 2, 3, 4, 5, 6, from the 6 filters, we can choose the optimal. Yeah, which combination is more, for example. Yeah, whether this one is median and Gaussian, or median, Gaussian, and Sobel, and I don't know. Yeah, we will see later. One is for when we select this filter, it will be denoted by 1, and 0 denotes that we do not choose this filter, right? And then after this, after we combine the outputs of the selection process, the output will be fed to the CNN model, and then from the CNN model we can have the log weight here, as well as to update the distribution of Bernoulli. Yeah, the Bernoulli distribution, meaning that the Bernoulli distribution controls. Yeah, the Bernoulli distribution controls the filter selection here. All right, that's the concept. So this is the algorithm. So we have the training data as usual. This one is the supervised learning. So this one is the image, and this one is the label. Okay, and we also have hyperparameters, yeah, which are number of samples and learning rate. Okay, and the output optimize the weight, yeah, the weight of the filter in the CNN here. Yeah, remember the CS filter. Yeah, that is the weight. Yeah, and also we want to optimize the filter selection probability, which is this distribution. Okay, and yeah, so actually this one is quite advanced. So at least what I want to say is that the research in machine learning and deep learning are very useful for everyday life. Yeah, so I hope it can trigger you to do the same. Okay, yeah. So we update the distribution and also the connection weights using these two equations, right? And then we continue to the image processing filters. So okay, so I have mentioned that the 6 filters, actually 7, because for Sobel we use vertical and horizontal. Yeah. Okay, so actually for the data set, this one is real data set. We obtained it from a hospital. Yeah, we have 245 excellent embryo and 599 moderate and 533 poor embryos, right? And then we need to resize the images to 1 to 8 times 1 to 8 because we use 3GG Yeah, you will need to see the requirement for 3GG Yeah, and then we convert the images to grayscale. Yeah, and then we divide. Remember, we divide the training and testing parts. Yeah, remember that training and testing must be independent, right? Must be independent. Yeah, cannot be related one another. That's why we use a random. Yeah, random separate. Okay, and then we do a bit modification in the VGNet. We use the global average pooling layer, and then we use softmax. All right, and here's the result for testing. So this one is our proposed algorithm, and then we compare our proposed algorithm with 3 more methods. The first one is no filter at all, meaning that we do not use this. Yeah, we do not use this. So we directly fit the image and view CNN, and then the second is we use all filters, meaning that we use all filter, meaning that all will be set to 1. Yeah, all filter are used. Yeah, so 1, 1, 1, 1, 1, right? And then the third comparison is with the random. Random meaning that we set probability to half for each filter. Yeah, for each image processing filter, we set the probability to half. Yeah, meaning that it can be selected or cannot be selected at the same probability. Okay, so it can be seen that our method has the lowest error, and then the highest error will be the random. Yeah, and then all filters and no filter will give the same, almost the same performance, right? And once again, that this one, because we have 3 classes, then the confusion matrix is 3 times 3. This one for no filter, this one for all filters, random and joint optimization. Okay, so we can see the accuracy here. Yeah, the accuracy. Yeah, in the this. Yeah, the correctly classified images, right? Okay, and then this one is probability of the filter chosen. Yeah, so it means that we can see Sobel vertical filter are mostly chosen. It's very dominant. Yeah, Sobel 5 times 5. Yeah, vertical Sobel 5 times 5 also quite dominant. Horizontal Sobel 3 times 3 also dominant. Yeah, Sobel horizontal Sobel 5 times 5. And median filter 3 times 3 and median filter 5 times 5. Right? This one is sharpen filter, right? 5 times 5 and sharp filter 3 times 3. Yeah, other filter can be removed lah. You can see that they are not dominant, right? They are not dominant, especially this one, Laplace filter 5 times 5, yeah, and Gaussian filter 3 times 3. They are not very dominant. Okay, so we can see that we have relatively the same accuracy for all scenarios. Yeah, and then excellent embryos tend to be predicted as moderate. So this is our weakness. Yeah, but in the embryologist point of view, it does not give at first effect, as both moderate and excellent embryos can be transferred. So actually, we want to separate the poor embryos only, right? And then we continue to the second one. Second one is the main is in human-computer interaction. Applications is about the hand gesture recognition, and then our work also has been published in IEEE Census Journal just in this year, 2021. And actually, we want to design low-cost capacitive sensor for sign language recognition, right? So the contribution of our work is just efficiency, right? So because we use capacitive sensor, so it will be low cost. And then the sensors are placed, the electrodes are placed in the finger phalanx, yeah, so that it has richer information, okay? And then different from other words, we provide 15 capacitive features. Yeah, once again, that this one is machine learning, that we need to define the features, yeah, separately. Yeah, it's different from the previous deep learning. Yeah, the features we do not specify the features here because the CNN will generate the features automatically. Okay. So here we define the features. Yeah, we have 15 capacitive features. Later we will see what are they. And then we use two types of machine learning algorithm. The first one is HVM. Yeah, it called HVM because we have more than two classes. Yeah, because we have 26 figures hand gesture. Yeah, 26 hand gestures to be classified. So we use ECOG SVM. Okay, and then we use KNN as well. Yeah, the nearest neighbor. Yeah, K nearest neighbor. Okay. This is our design sensor. Okay, so this one is the sensor. This one is the electrode attached to the phalanx of the fingers. Yeah, so actually something like this, yeah, something like this. And then we have the capacitive measurement, yeah, between the fingers, yeah, and also between the fingers and the ground. Okay. Okay, so these are the 15 features. Yeah, so the 15 features are the capacitance from electrode 1 to electrode 2. Yeah, electrode 1 to electrode 2, electrode 1 to electrode 3, yeah, and so on. And then from electrode 1 to the grounded elbow, yeah, to the grounded elbow, yeah, and then electrode 2 to the grounded elbow, and so on. Okay, so we have 15 features. Yeah, we will give richer information. Yeah, about the gesture. Okay, so after this we do the gesture, 26 gestures. Yeah, I think we, if I'm not mistaken, we had 10 participants, right? 10 students participated in our research. So each student will do 26 gestures here. Yeah, and then we will get something like this. Okay. This is, for example, we use the gesture A. Yeah, we will get something like this. Yeah, for channel 1 and channel 12, meaning that the blue one is this. Yeah, the green one, channel 12, is the capacitance from electrode 2 to the grounded elbow. Yeah, just for example here. And then we use the running median filter to smooth the pulse here. So we get this. Okay, we get this data. Yeah, so we have data for 26 figures, and then from 10 10 participants. All right. And then we use the ECOG SVM and also KAM with K is equal to 5. But beforehand, we use the knowledge data. We use the minimum maximum normalization using the formula. Okay. And also by looking at the correlation matrix. Here, we generate the correlation matrix here, by the way. And then we see that most of the, some of the features are correlated. Yeah, some of the features are correlated. That's why we can compress the features. Yeah, I think we compress the features to 5 only, right? Why we need to compress the feature? Because we want to reduce the ML complexity. We want to reduce the model. Remember the Occam's razor principle that we choose the lower complexity one than the more complex model, right? And then this is the result. This is actually the accuracy, yeah, for training and testing. Okay, so this one for ECOG SVM, and this other two is for KNN. Oh, sorry, this one is for KNN. Okay, this one is for KNN, and this one is for inter-participant training, meaning that for inter-participant, meaning we know which gesture is this. Yeah, we have 10 students. Remember, we have 10 students. This one is from student 1, student 2, or student 3. Yeah, and then you can see that the accuracy was quite good. And then the little difference, yeah, between the compressed data and the full data, yeah, complex features and the full features, right? Therefore, we can use the compressed feature, yeah, to simplify the model. Yeah, we can use the compressed. You can use the compressed data or compressed feature to simplify the model, right? And then, as I mentioned previously about the challenge of the machine learning, so when tested with leave one subject out cross validation, the accuracy falls to 5 to 20%, meaning that we do not train, for example, student 1. Yeah, we do not train student 1. We leave the student 1. We only train the data from student 2 until student 10, right? And then we test using the student 1. Yeah, student 1 as the new data. Yeah, so the accuracy falls to 5 to 20%. Only 5 to 20%. Previously, it's above 90%. So meaning that it's consistent with our description previously, that the distinction, yeah, the independency between the test and the training data, yeah, should be more developed. Yeah, should be developed. Yeah, how to create the interdependency between the testing data and also the training data. Okay, so that's why the capacity measurement is user dependent. So it will be different. So my data will be different from your data because the fat content of the finger is different. That's why the capacity also different. Okay, and then for the next one, we can use a generalized mathematical model that will work for all signers. Yeah, so this one is another challenge. Okay. Okay, I think that's all the sharing from me.
Thank you, Dr. Philbert. Such a nice session from you. And I guess you have, am I audible to everyone?
Yes, sir.
Okay, fine. So I guess you have taught us today the weak versus strong AI and autonomous car using various sensors. And of course, where does ML come from AI and how deep learning comes from machine learning? And what is learning and what is machine learning? performance, task, and experience, face detection, and of course, various patterns which coming under recognizing, and also prediction, and of course, elements of AI you have taught us, and types of learning, which is supervised, unsupervised, semi-supervised, and of course, reinforcement learning, and how to reduce the loss, supervised learning using classification techniques, regression, and logistic regressions, evolution matrix, and challenges in machine learning, remarks of machine learning. And of course, you have shown us some sample data sets. How does this automatic detections works? It was really quite a good section. And thank you very much, Dr. Philbert. Over to Purva ma'am.
Yes, thank you, sir. I again thank you to Dr. Filbert Hilman sir and Dr. Satish sir. On behalf of IST, IIP, IMR and the entire supporting team, I would like to invite Dr. Keshav Patidar sir, Principal IST for vote of thanks. Sir, please.
Good afternoon, everyone. We are very much fortunate to have such an eminent person from academia with us. I'm sure that all the participants must have benefited a lot by attending this webinar. It is my privilege to have been asked to propose vote of thanks on this occasion. On behalf of IST, IIP, and IMR, I extend our most sincere thanks to Dr. Philbert Hilman, expert speaker from Curtin University, Malaysia, for accepting invitation and giving opportunity for interaction and enlighten all of us about machine learning and its applications. I extend my most sincere thanks to Shri Arun S. Bhatnagar sir, Director General IST, IIP, IMR, for wonderful session on machine learning, and also for guidance, for providing all the support for conduction of this event. I also take this opportunity to extend our sincere thanks to all the participants. At the last but not the least, I want to thank each member of our organizing team, especially Dr. Satish Kumar and all the team members for their sincere effort to make this session successful. I once again thank everyone whose contribution has made this event successful. Thank you all.
Thank you so much, sir. Thank you.
Thank you, sir.
Thank you, sir.
Recording stopped.